So in the previous lecture, I was discussing about electrophilic substitution reaction, nitration of the benzene. How benzene react with nitric acid, concentrated nitric acid in the presence of sulfuric acid to produce nitrobenzene I was discussing about. In continuation to the electrophilic substitution reaction, there is one more halogenation also. That means arenes react with halogens in the presence of Lewis acid, anhydrous compounds, ferric chloride, ferric bromide, aluminum trichloride, and producing haloarene compounds, halogen derivated compounds. Example, the benzene react with halogen, chlorine or bromine and produces bromobenzene. That means here benzene is a compound. Benzene is the compound. Example for arenes. So when benzene react with halogen, if you take example of halogen is bromine, if you take bromine, you can take chlorine also. You can take the Br2, bromine if you take, and so bromine, when benzene react with the bromine, it produces the compound we get is that bromobenzene will get bromo plus the byproduct we can get is HBr. So when benzene is the compound that react with the bromine and form bromobenzene plus HBr we can get. And remember, this reaction is not addition reaction. This reaction is electrophilic substitution reaction. Unlike alkenes, benzene react with the bromine or halogens in different to form halo-derivated products. So this is what we call bromination. We say it is a bromination, we can say bromination of benzene. And this is the reaction is taking place in the presence of ferric bromide. This reaction takes place in the presence of ferric bromide. In the presence of ferric bromide, the reaction takes place. Let us look into this mechanism of bromination of benzene. How the bromine react with the benzene to form the bromobenzene. We'll look into the mechanism. In this, if you look into the mechanism of the bromination of the benzene mechanism, if you look into this, in step 1, what happened in the step 1? Activation of Lewis acid. For example, we are taking Lewis acid is ferric bromide. This is the ferric bromide. The ferric ion is bonded to this 3 bromine atoms, ferric bromide. So which is Lewis acid property, it has Lewis acid property, electron deficient we say. This is the Br2. When Br2 approaches this Lewis acid reagent, the lone pair of electron is given to the iron because here iron is Lewis electron deficient, iron is electron deficient here. The lone pair electron is given to this iron. As a result of this, there is bromine bond is polarized because of lone pair is converted to sigma bond here. Lone pair is converted to bond. Then there is bromine bond is broken. Bromine bond is broken here. When the bromine bond is broken, there is electrophile is produced. So then ferric bromide changes into nucleophile. So this step is said to be what we call means activation of Lewis acid, we say activation of Lewis acid, or the bromine bond is broken heterolytically, or generation of electrophile. That means Br sorry, so Br plus ion is formed, electrophile is produced in this. So this step is otherwise called electrophile generation. This step is otherwise called electrophile generation. Step 2, if you look into the step 2 of the mechanism, the generated electrophile, this generated electrophile. So I would like to array this. So here the electrophile that is generated in step 2 attack this bromine electrophile attack this benzene ring, since the benzene ring consisting of pi electrons, the bromine plus ion attack this benzene pi electrons. So pi electrons is given to this bromine and this Br becomes a negative. Look at this, the pi electrons given to this bromine. So now this bromine is linked to this carbon, and so here on the benzene there is carbocation is formed. Then this is FeBr4 minus is produced and carbocation is formed on the benzene. One bromine is attached to the carbon here, electrophile is attached. This is carbocation intermediate compound. This is called carbocation. So once the carbocation is formed, it undergoes resonance structure. Delocalization of pi bond electron takes place within that. So we can get resonance forms. And this carbocation intermediate. So when this carbocation means undergoes stabilization, the sigma bond of this hydrogen converted into pi bond inside in order to neutralize this positive charge. Then this proton is taken by this Br. So ferric bromide, this anion complex will take this proton and forms into ferric bromide and HBr is produced. Look at this reaction here. So the third step that takes place here is that deprotonation.